Hey everybody, it's Robot here from Vespa Motorsport and ScooterWest.com. So this is essentially part 2 of an engine rebuild. This is the video that no one else would put out, because you see restoration videos all the time. Do you ever see a restoration video where they're actually showing how to mic out all the parts and check the tolerances and just a general inspection of the parts? You know, when I hear the word rebuilt, what does that mean? You just took the old worn out parts, you put it back in the motor? I mean, that's a lot of times what it ends up being, but you kind of want to inspect several critical parts of the motor before you put it back together. Oftentimes, you know, if it's jumping out of gear, I'll show you what to look for, but just doing general inspections like checking the piston and the ring end gap clearances, checking your crankshaft. Obviously, a do-it-yourselfer is not going to have a set of V-blocks and be able to true the crankshaft. There's a lot of stuff that's kind of above the realm of a normal do-it-yourself home mechanic, but I'm going to try to cover everything you can do as a home mechanic with just a basic set of feeler gauges, not even, you know, micrometers, or, you know, it might be useful to have a caliper here, but you know, and I have some factory tools for doing measurements, but I'll show you how to do it just with a basic pair of feeler gauges. So let's get right to it. This is gonna be a nice, boring, long video for you guys. All right, so we're gonna start with the piston and cylinder, which is kind of the heart of the whole engine. I have no reason to believe that this thing is heavily worn. We'll check to see if it's got an oversized piston, which I do assume it does based on the miles. It had tons of power, it ran great. It just leaked oil, so that's why I took it apart. So we have the piston right here. It looks to be in pretty nice shape. I already removed one of the rings. I already decarbonized it, which is typically kind of some of the steps you want to do. You can see there's a couple seize marks around here. So the piston has seized in the past. It's not necessarily a bad thing. You know, I'll take my nail, I'll run it across those seize marks. I could barely even feel those seize marks with my nails. So, I mean, you could take some emery cloth and clean it up a little bit if you wanted to, but I don't have any reason to want to replace this piston. I don't even see that much carbon in the grooves. Oftentimes, if it's a pretty high mileage piston, you're gonna have a lot of black carbon buildup in the ring gaps, and ironically, usually you just want to break a ring, and you could use a broken ring as something to scrape it. So I got one of the rings removed. You can remove the rings kind of carefully with your fingers. You want to keep them in order if you are going to reuse them, but I have the top ring in place. There is also a specialized tool. This is an old Snap-on ring expander right here, and pretty much just expands the ring, so I'm able to get it out. Now, oftentimes, that's kind of a typical problem. You'll end up getting it stuck in the top groove when you're removing the lower one. Definitely takes a lot of feel for getting these rings out. A lot of times as a do-it-yourselfer, first time, you may end up breaking the rings. Take care, sometimes they're very sharp. But we're gonna start by looking at the piston right here. And I do see a little engraving on here. I see a little arrow that points towards the exhaust. You barely see it. I don't know if the camera gets it, but I do see 66.9. So the original size on a P200 would be a 66.5, and that measurement is the measurement of the bore, not the piston. You know, there's a clearance between the pistons, so the piston's a little smaller. But 66.5 is the original size. Then they have first oversized, which is 66.7, and then 66.9. My instinct is a lot of times when you have a pretty seized up or worn out cylinder, sometimes you got to skip an oversize. So in the past, this has been bored out. The cylinder's been bored to about 66.9. We'll measure that to verify it. But like I said, I have no reason to believe that this is pretty worn. This piston looks pretty good. It looks fairly new. You know, it does have some carbon buildup, so it's got a couple thousand miles on it. So I got the lower ring. We have the upper ring. It's already in the bore right now. So here we got the top piston ring. There is a measurement for the gap, but a lot of times you put it in there and this is fine. There's a little bit of rock and clearance. I mean, you have to have a pretty heavily worn piston where the rings are flopping around in the ring and groove. I'm not gonna go as far as talk about the measurement. You'll have probably other egregious worn out parts of the piston or cylinder before you'd have worn out ring and gaps. So the rings are lined up on 2-strokes with these little pegs right here, and you can see the little peg notches right there. So oftentimes is what you do is you drop the piston ring right into the cylinder here. That's the first thing I'd check. And we'll push the ring in probably, I don't know, like about a 1/2 inch. Don't push it more than like 2 inches in. And I'll tip this over. And at this point I see a gap. The gap looks pretty good just from instinct of looking at cylinders, but you want to take your handy dandy fielder gauge, and you can see the markings. This is has standard measurement in thousandths on the top, and then the lower measurements in hundredths of a millimeter, or hundredths of a millimeter, so 0.66 millimeter. And you just give one a try and see that's too thick, and we'll work our way down. So we'll try 16 thousandths, 0.4 millimeters. We can go a little thicker. Maybe 18 thousandths, 0.45. That doesn't fit in there. And then we have 17 thousandths, 0.432. And that's kind of a tight fit. So I'd say it's about 16 thousandths, 0.4 millimeter gap is pretty much what our ring end gap is. And the standard ring end gap when you're setting up a new cylinder should be 0.25 to 0.4 millimeters. And the service limit's actually 2 millimeters. I would replace it if it was a millimeter. So if you measured a gap of a millimeter, I would definitely replace it. But if you're starting with a new piston, oftentimes you need to, or new rings, you would need to file the gap to get something between 8 thousandths to 16 thousandths, or 0.25 and 0.4 millimeters. But that's perfect. We could try, this is my lower ring. You pretty much just do the same steps. So that's my upper ring. Keep them in order. Do the same thing. Just push it in about a 1/2 inch down there, and I assume that's pretty much the same gap. So the 0.4 fits in there just fine. So no problems with the rings. Again, keep them in order. So I usually look inside the cylinder. I'll run my nail around there, and if I'm catching grooves with my nail, I do see some grooves in here because the piston has seized in the past, but my nail isn't really catching it. And I would have checked the compression of the cylinder. You know, if I saw 100, 125 PSI when you're holding the throttle wide open and kicking it through to check the compression, I should have showed that before I took the motor apart. I would have suspected the rings and the piston and everything were in good shape. So the quick and dirty way to check the clearances of your piston, this feels pretty good. Usually you don't want to put it in from the top. Sometimes it will bind up. You do have the arrow that points towards the exhaust, so kind of keep it oriented the same. So when you start with a fresh bore, usually we'd tell a machine shop to pretty much cut the cylinder 3 or 4 thousandths. And that's the clearance between the piston and the cylinder. And the easiest way to measure is just with a long set of feeler gauges. This isn't something you find too easily. So start with like a 3 thousandths. We'll push the piston in from the back. And you can see it goes right in there, no problem with that 3 thousandths. And I'm pretty much just more or less concerned if it's outside the clearance. So if it was over, 10 thousandths or 0.25 millimeters, it's definitely tying to the bore cylinder. I'll try a 6 thousandths or 0.15 millimeter. I'll try that again. and you kind of slip the whole feeler gauge in there and then push the piston up, and you can see that's too tight. The piston's not going to go in there. I don't think we're going to have any problem. The 3/1000 was pretty smooth. My assumption, if I really wanted to figure it out, it's probably 4 or 5/1000 is what the actual clearance is right now. Try sending a 4 down there. So point was 4/1000 0.15. So that's getting a little tighter. So it's probably 4 or 5/1000 is what the current clearance is. And that's perfectly acceptable. The other way you'd measure a bore, which isn't a typical tool, you definitely don't need this as a do-it-yourself technician, is you'd have a set of bore gauges. These are really old at this point, and they're pretty difficult to use if you're, not familiar with how they use, but it locks the little pin in there, and we would get this. Usually you measure it about 1 inch down, 30 millimeters down, something like that for a 200 barrel, and it releases, and then you lock this, carefully lock it, and then you carefully rock that out, and you're able to use a micrometer to measure the bore. And my guess is this cylinder is really, really close to 66.9. And if you're looking to measure a piston, a micrometer is going to be a little bit more accurate than a set of calipers, but you can get pretty decent, inexpensive digital calipers for not all that much money. And the way you'd measure a piston is typically in between this port and this lower ring, and a lot of times you measure in a couple different spots. So that's 66.61. So 66.52. And that kind of, if you do the math, it's pretty much when I sent the feeler gauge down there, similar to that clearance that we end up measuring. Again, that's probably going overboard. If you just need to verify the piston, you just go a couple thousandths over what you measure, and it gives you your piston. If you're wondering how the oversizes work on vintage Vespas, like I said, the original is 66.5, 66.7 is millimeters is first, and then second, 66.9, 67.1, and there's sometimes even 4th, 5th, and 6th oversized I've seen in the past. So at this point, I've kind of determined that the piston and cylinder and all the clearances are definitely within an acceptable range to reuse them. For right now, I'll just put the rings in there just to hold the piston in place. Be careful not to put the ring and gaps where the port holes are, because then you end up sometimes with a ring that's stuck in the piston, but that just kind of holds it all together, and we'll come back to that when I reassemble it. Sometimes if you are going to replace the rings, maybe your rings were out of specification, you just wanted to re-ring your piston, you would send a hone down here. Obviously the easiest type of hone to use is a ball hone. Unfortunately, those are pretty sized to fit certain cylinder ranges. But I don't really see a reason to do that. The engine was running so good, I'm gonna leave those rings and everything. So next I'm gonna talk about the crankshaft. A do-it-yourselfer is probably not gonna have a truing stand to check the crankshaft for true. I'm certainly gonna check it out. That might be something you wanna bring to a machine shop and have them check it for true. And there's a couple things you check. When you have it in the V-blocks to support the crank, you'd put a dial gauge, obviously missing that little Woodruff key right there and right there. And the idea is you have less than 1/1000th of an inch run out on both these ends. And then you'd also check the rotary valve surface. So this is the actual surface that opens and closes the intake port, essentially the valve for the intake charge. And you want to make sure this has less than 1/1000th of run out. I think the official spec is like 0.02 millimeters or something. It's definitely less than 1/1000th if I recall. But it needs to be, it runs within really close proximity to the engine cases. The next thing you want to check is your wrist pin bearing. So this feels good. I just do the fuel vision test. You kind of just put the pin in there. I see the wear is really nice on this gudgeon pin right here, and the bearing feels pretty nice. It probably was replaced when that piston was replaced and the cylinder was bored out. And right here on the end, I see one little hash mark. And the way that works, there's 4 categories for these bearings. There's essentially 4 categories for the connecting rod. And I'm talking about the original connecting rod. Oftentimes, if you replace it with a replacement aftermarket crankshaft, it's going to just come with a sized wrist pin bearing. And they don't really do the marks. But if you have the original crankshaft, there's going to be one slash mark on the connecting rod. And that indicates that you use a category 4 wrist pin. And sometimes they're color keyed. Sometimes you'll see 4 slashes on the end of the wrist pin bearing. Bearing has been replaced. I don't know how accurate you need to be. I'm sure you could go 2-3 sizes off. It's not going to cause any issues. I've never heard of it causing any issues, but that's just the way they were sized originally from the factory, and we still do sell all 4 categories of these wrist pins. So essentially the way this system works is you take, if you see 1 hash on the connecting rod, you need 4 hashes on the wrist pin. So the sum totals to 5. So if you have 3 hashes on here, you'd use a 2 hash, category 2 wrist pin. So whatever the number is, it totals to 5. So these wrist pins are all the same. The wear looks pretty nice on this, but if there's any pits or any abnormal wear on this, I would suggest replacing it, or the piston includes a new wrist pin. Also, if I see kind of odd wear, where you only see wear on one side, I would suspect either crankshaft's severely out of true or it's got a bent connecting rod. So it has really nice wear, so I'm not too concerned with that. I'll check this for true in the V-blocks, and I think we'll just put it right back in. I have no reason to believe that there's issues with that. So here is the lay shaft right here. I don't see much abnormal wear, where the gears. So it's definitely, always had gearbox oil in here, which is a good thing. The shifting cross looks to be in pretty serviceable shape, but typically my thought is you replace the shifting cross every time you do a rebuild. It's just a wear item, and obviously it engages between the 4 speeds, and then you got neutral right there, so it stays between the pair of gears. But there is one thing you do want to check. We're going to check the gear end shim. This is a P200E, so it's only shim from the one side, like all the prior years of motors. If you have a PX, it's going to have what they refer to as an EFL gearbox, so they have a shim on both sides. A little different to set up, but pretty much the same measurements. So we're going to go ahead and assemble the gear stack. And each one of these gears, I'll look all the way around, and I'll specifically look at these little edges right here and see how square they look. I took this scooter on a good test ride. It wasn't popping out of any of the gears, so I don't have any reason to believe that the gears are worn. This gear right here, the smallest gear, is going to be your 4th gear. You can see it's got this little ridge here that's going to face up. So we'll go ahead and drop that onto that shifting cross. And we've got 3rd gear. We'll do the same thing. We'll kind of look at these little edges. They look all to be pretty square. They just have a small chamfer, which is pretty normal. Go ahead and drop the gear down. And you can see the gap. Kind of pay attention to the gap. If you put the gear in the wrong way, but you can assemble the engine, the gap's very large and it shouldn't be that way. And you can also look at the wear on the lay shaft itself, and this metal surface rides, it's kind of added the wear, so you could kind of pay attention to that. It's kind of bad news if you assemble the gearbox in the wrong order. Next, we'll take our 2nd gear, and the way this one is assembled, there's a much larger gap, which is our neutral between 2nd and the 1st gear. Usually 2nd, 3rd gear are the ones that show the most wear. They look very nice. I assume with this many miles on this scooter, it probably has had a gear or 2 replaced. They are original Piaggio gears. And then we have 1st gear, and the flat side faces towards the top. And this gear, I would say, shows the most amount of wear, and it still is definitely acceptable. And we'll drop that in place on the top. And I'm using the hub to kind of support the drive shaft or the lay shaft right now. So here's the gear shim. And typically I like to measure the gear shim before I put it back in place, see what's on there. So right now I'm measuring 2.5 millimeters, which is a third over shim. So the shims, if you have the standard size shim, it would be about 2 millimeters or 2.05 millimeters. A first over is 2.2 millimeters. A second is 2.35, and a third is 2.5, and there's even a fourth, and I think there's even aftermarket shims that even go larger, but you probably have more issues if you're going any larger. You may have wear in the gears if you're going over. So I take the circlip, it's got a sharper edge, I'm going to have that face up. We'll go ahead and use our external circlip pliers, put that circlip back in place, put your fingers over it so it doesn't go flying across the room. Don't stretch it any more than you have to. And if you're wondering how you'd measure this with the factory tool, this is not available. This is the factory feeler gauge that measures the gap. So the minimum gap is going to be this feeler gauge, which is 0.15 millimeters. And I could tell this is a pretty tight gap, and that fits in there just fine. So I'm pretty certain the shim that's in there is pretty good. But you use the thicker gauges so you could get a judge for to go one size over on a shim, two sizes over, or three sizes over. But that's how the original feeler gauge setup works. But I'm going to show you how to do it with just standard feeler gauges. So we'll start with 6/1000ths, which is 0.15, and you need to have a pair of feeler gauges to do this. So we'll find another one, another 6/1000ths. And you'll slip it right underneath. And that's pretty much the minimum clearance. So they fit under there just fine. For example, if I measured that gap and it was 0.5 millimeters, that's where you need to go to the next size shim, or sometimes two sizes shims over if it's going to be 0.5 millimeters or larger. That's quite a big gap. The normal clearance for this is between 0.15 and 0.4 millimeters. So 6 to 16/1000ths. It's definitely at the minimum of the gap, which is a good thing. It makes for a nice quiet gearbox. So that shim is definitely the correct size shim, having that third over shim that's already set up in this gearbox. So keep in mind that is the minimum clearance. So 0.15 millimeters or 6/1000ths. If I couldn't get this pair of feeler gauges, the 6/1000ths on both sides, if that's the case, you got to go one size smaller with the shim. So if it was any tighter than this setup, I'd probably go down to a second over shim, which would be 2.35 millimeters, which would give me, if I put that in there, we would probably end up with a 0.35 millimeter clearance. So, and you'd definitely be within the specification. That's between 6 and 16/1000ths, or 0.15 and 0.4 millimeters. Sorry, I'm jumping around units, but this is the United States. We kind of use those goofy units called the inches and thousandths, and I kind of just want to talk about both of them. So, and how our silly feeler gauges have both. But our gearbox is all set up. I have no reason just to put this back in the way it is, but I'm probably going to put a new shifting cross in there. One more thing I like to look at, if I put this in a set of V blocks, I would make sure that this little gap is, so the selector spindle is pretty easy to distort. This is a pretty fragile part, but I'm pretty certain it's still in pretty good shape. So I pretty much covered some of the critical measurements that you do want to check before you assemble a vintage Vespa, specifically this P200. One other thing that I'll probably do before I put this back together, you can see somebody sprayed like copper sealant on here. That's an optional step, and they never really had that. but anytime you remove the head, usually you want to relap this surface into the cylinder. And I do have a micro flat, and sometimes I'll put emery cloth, and in a circular motion, I'll kind of take down a small amount of the surface of this head, and I'll kind of look to see how the micro flat and the sandpaper takes it. You want a nice even finish. But oftentimes that's kind of going overboard. This looks to be in pretty nice shape. Is what I do is clean all this up. I'd put a little bit of valve grinding compound, and we would actually just grind the cylinder head into the cylinder. And that's all you need to make a good seal. Obviously, after you do that kind of step with both coarse and fine valve grinding compound, you want to clean all these parts quite a bit, make sure they're perfectly clean. So one thing about this cylinder head, this isn't the original cylinder head. This is a P200E cylinder head. It's actually a later revision. We do sell the original Piaggio cylinder heads, and they would look just like this. This is a revised design where they added these extra little tabs that keep the head from warping. It adds for a better clamping force when you bolt the cylinder head studs down to the, when everything's bolted down. So it's just a better design. The original head that was found on a Rally 200 or any of the smaller displacement models or the early P200s would not have these little tabs right here. All right, so in my next video, I'm going to show how to assemble your Melosi engine cases and how to put all new bearings into those brand new cases. Or if you have the older cases, I already showed how to knock out the bearings. Bearings, they're pretty hard to judge. It's more or less, if I heard a lot of bearing noise from the motor, that's where I would suspect replacing the bearings. Keep in mind the bearings are pretty inexpensive, and you have high miles or there's other issues with the motor, you're putting a new crankshaft in it, just splurge and spend a little extra money to replace the bearings. There's some bearings that you can leave alone, such as this outer lay shaft needle bearing. They tend to last quite a long time. But the crank main bearings, the wheel bearings, those are all bearings you want to replace. So I'm not going to mic those out. They're pretty difficult to do measurements on them. But that pretty much covers the critical things you want to look at. I'll cover assembling the clutch and some other things I look at when I put the clutch back together. So there's my boring before you do assembly on a rebuild video on a P200. Thanks for watching. It's Robot here from Vespa Motorsport and ScooterWest.com. Look out for the next video. Thanks for hanging in there. We'll see you on the next one.